Hello! This week you are going to start designing your boat. Let's take what we learned last week about what makes the greatest volume and just talk about that as you start your design. Last week we noticed that the more boxes you cut out, the volume started growing more and more and more until it got to a certain point. And as you can see from this graph right here, it looks like when it got to 3 units high and 14 with the length and the width, that was our maximum volume. Now you probably didn't get to cut this out, so I just wanted to show you pictures of what this looked like. Looked like that. That was the greatest volume. Not too tall, but not too short. This was the next greatest. This was 4 units high. This was the next greatest. That was 5 units high. And then the two smallest volumes were the really shallow, flat boxes. Just keep that in mind as you start your boat design. Did you notice that last week the most surface area was at 400, and then as soon as we started cutting out corners, the surface area actually decreased. So interestingly enough, this box right here, let me see if I can put my pointer on here for you. This box right here used less tin foil or less paper than the first box, but yet had a much greater volume. Just keep that in mind as we move forward. This is the Nearpod lesson that you probably didn't get to watch. So I'm doing this with you so you can remember what to do. Describe the shape of the box with the greatest volume. I don't know if you noticed, but from those pictures I showed you just a second ago, the box isn't too tall, it's not too short, it's kind of proportional. Keep that in mind as you build. Try this. So now I'm going to show you how to do an applet online. This is going to be really helpful to you as you build your own boats, which are really going to be shaped like boxes usually. You might get crazy and do something different, but this is where we're going to start. I found this website that will actually find the volume and the surface area for you so you can play around with it. So we're going to try two different size boxes. We're going to do our 18 by 18 by 1 and our 16 by 16 by 2 boxes. And we're going to compare the surface areas to see if they were the same as what we got. So I'm going to include this website in the next activity on Schoology, but here let's take a practice at it. This is the actual website. And as you can see, it actually allows you to type in the dimensions of the box. So we had a width of 18, we had a height of 1, and we had a length of 18. That was our first box. Let's check the volume. Now it says our volume was 324 cubic units, right? And I believe that that's exactly what we got, which is great. But now I want to go back and have it figure out the surface area for me. So I'm going to do the same box again, 18 by 1 by 18. And this time I'm going to go to this drop-down box and I'm going to click surface area. I know for a fact we did not get 720 for our surface area. I wonder why. Oh, I know why. Our box doesn't have a top. So what we would have to do is remove one of the tops. Well, the top has a width and a length of 18, so 18 times 18 is what we need to remove from that. Keep that in mind as you work forward. Let's try it again with another one. What if we did the 16 by 2 by 16? Oops. As you can see, all you do is type it right in and then make sure you click surface area. Okay. So check this out. The surface area is much greater than we had. We had something in the 300s. So we would have to do 16 by 16, which is 256, and subtract that from 640, and that would give us the correct surface area. But at least it's a start. It makes things a little bit easier for you. So is this what we calculated last week? This is the one I just did with you. And it says that we should have 640, but we know that that's absolutely not true. So if I was able to write on this, I would, but for some reason I can't. You need to subtract off the top every single time you do it. It doesn't take much, but it'll help you a little bit. So find the correct surface area of this box. We need to subtract the area of the top of the box. I'm going to Edpuzzle this so you'll have to do it on your own. All right, so this is the second part of our boat building. Oh, hold on a second. I skipped too fast. Okay, so we're going to start our boat competition. And the boat competition is that you're going to build a tinfoil boat, and rewards will be given out for the closest predictions, the top 3, the most unique boat design, so no, you don't have to build a square boat, the greatest volume, and the greatest number of boats predicted and tested. So in other words, if you come up with 3 different designs and you're the only one that came up with 3 different designs, you also get a reward. These are the things you're going to need. But for right now, the only thing you really need is your calculator and your computer, because the first thing we have to do is just design the boxes. Then you'll probably need a piece of paper and a pencil, because then you will start drawing the actual design of your boat. But as we get done with our designs, you are going to need tin foil, you are going to need some tape, you definitely will need a ruler, and you need as many pennies or coins as you can find. If it floats your boat. So one thing we have to keep in mind as we build our boats is, what does it take to float a boat? And to float the boat, we need to make sure our boat has less density than the water it's floating in. So the density of water is 1 gram per centimeters cubed. So we need to make sure that we don't put more than that in our boat. So if the object is denser than the fluid, it will sink. If the object is less dense than the fluid, it will float. If the object has the same density as the fluid, it will not sink or float. We are going to be floating our boats on water, and there's the density again. I just want to show you an example of my boat. I had to put quarters in mine because I did not have enough pennies. Quarters weigh more. Now you're thinking in your mind, well, wait a minute, quarters certainly weigh more than water, they should sink, but keep in mind they are being displaced because they're spread out on top of this foil boat. So that's what we need to design. The greater the volume your boat has, the more it can hold. Keep that in mind as you go, ooh, that was the last one and I sunk my boat. When your boat sinks, that means the density is greater than 1. So, reminder to you as you are building your boat, the greater your volume, the more cargo your ship can hold. Next step, this is your job this week. You are going to come up with at least 2 different boat designs. One should be a rectangular prism. You will need to submit to me by the end of the week your drawings of your boat designs with the dimensions labeled. You will need to find the volume. And the surface area must be less than 144 centimeters cubed. This is important because really we won't have enough coins to put in here. And I'm sure the bottom part of this slide is cut off for you. I apologize, I'll read it to you. You might want to cut out a 12 by 12 sheet of foil to see how big this is, or a 12 by 12 sheet of paper. When I say 12 by 12, I mean 12 centimeters on each length, on each side. That is really what you're starting from. Remember to check your surface area. It should never be more than 144 centimeters cubed. Good luck. Let me know if you need help.